Welcome, geometry students. Today we're going to learn how to use properties of parallelograms to solve problems. So today's the first opportunity for us to talk about a specific type of quadrilateral. This whole unit is all about the various types of quadrilaterals, such as squares, rectangles, kites, and so on. So the first type of quadrilateral we're going to be talking about is a parallelogram. So a parallelogram is a quadrilateral, meaning a four-sided figure, with both pairs of opposite sides parallel. So if you look in your annotation section, there's a drawing of a parallelogram. And essentially, if we look at a parallelogram, we need to know that both pairs of opposite sides are parallel. So if you look at this image here, you can transfer that over in your annotations. One of the traits of a parallelogram deals with its opposite sides and angles. So if a quadrilateral is a parallelogram, then its opposite sides and opposite angles are congruent. So we already saw that the opposite sides are parallel to one another. But now we're adding to that, if it's a parallelogram, it's also going to have opposite sides being the same measure and opposite angles congruent to one another. So these two angles are congruent, and the angles across here are also going to be congruent to each other. So that's an important element to know about a parallelogram. Example 1 says to use the properties of parallelograms. We're going to find the values of x and y. Well, if we look at this parallelogram, first of all, we know it's a parallelogram because it's a four-sided figure with two pairs of opposite sides parallel. So since that's true, we can assume it to be a parallelogram because it has all the evidence showing it to be so. Now what we're going to do is use the fact that it is a parallelogram to know that the opposite sides are not only parallel but also congruent. So if x plus 4 is congruent to the length of 12, we can make the equation that x plus 4 is equal to 12. When we solve that, we're going to find that x is equal to 8. So we've accomplished one goal, knowing that the opposite sides of a parallelogram are congruent. Now we're going to continue on and look at the angle measure for y. Well, one of the traits of a parallelogram is that the opposite angles are congruent. So if y is opposite of angle C, or in this case a 65-degree measure, that means that y must be equal to 65 degrees. So we were able to find x and y using the traits of the parallelogram. Another trait of a parallelogram is dealing with its consecutive interior angles. So if a quadrilateral is a parallelogram, then its consecutive angles are supplementary. Again, over in your annotations, there's a picture of a parallelogram. So basically what we're saying here is, if this quadrilateral is a parallelogram, then we know that the consecutive angles are going to be supplementary. Well, just keep in mind that consecutive means angles next to one another. So if I have this as parallelogram ABCD, then the angles next to one another would be, for example, angle C and angle D. These are going to be supplementary. Likewise, angle B and angle C are supplementary. Angle A and angle B are supplementary. And finally, angle A and angle D are supplementary. Now, the reason why this works is all about the parallel lines. So if we go back to the original definition of a parallelogram, we were told that both pairs of opposite sides are parallel. So if I extend these side lengths, essentially what I have is two pairs of parallel lines cut by two transversals. So thinking back to last unit, we learned about all sorts of angle relationships. So if we think about, for example, angle A and angle D, and we look at that as our parallel lines and our transversal is segment AD, then those are consecutive interior angles. And if you remember, when the lines are parallel, the consecutive interior angles are always supplementary. So we could repeat this. Now look at transversal BC. Then essentially, angle B and angle C are consecutive interior angles, and therefore, since the lines are parallel, it would make those supplementary as well. So we could repeat that again for the other angles, but I just want you to be aware that the parallel lines that are related to parallelograms is a really important tool in finding unknown angles, just like it was in the last unit. All right, example 2 says, if KLMN is a parallelogram, find the values of x, y, and z. Well, let's start with x. We know that the opposite sides of any parallelogram are going to be congruent. So therefore, 2x minus 3 is equal to 37. Go ahead and pause your video and solve that equation. Okay, you should have found that x is equal to 20. If you did not, please pause again and revisit the steps in solving that equation. So we know x is equal to 20. Now we need to find y. Well, if you notice, angle N is equivalent to y degrees. We know y is equal to 123 degrees because the opposite angles in a parallelogram are congruent. Now the last thing we need to consider is how we would find z. Well, I can't just look at the angle opposite of z because that would be angle M, and we don't know anything about that. But what we do know is that the consecutive angles, or the angles next to one another, are supplementary. So essentially, angle L plus angle K will make 180 degrees. That's the definition of supplementary, as a reminder. So if we know angle L is 123 degrees, and angle Z is equivalent to K, then we can use this equation to find angle K, or the measure of Z. So by subtracting 123, we're going to find that Z is really the same as 57 degrees. So as a recap of this problem, we know opposite sides of a parallelogram are parallel and congruent. We know opposite angles are congruent. And we know consecutive angles, meaning angles next to one another, are going to be supplementary. All right, what about the diagonals of a parallelogram? Another trait that you need to know about a parallelogram is that the diagonals are going to bisect each other. So if a quadrilateral is a parallelogram, then its diagonals bisect each other. You have an image in your annotation, so please go ahead and add this to it. So we know this is a parallelogram. If quadrilateral is a parallelogram, you can abbreviate, by the way, parallelogram by replacing the word parallel with two parallel lines and ending with ogram. So if this quadrilateral is a parallelogram, then what we know is that if you connect the diagonals, by the way, the diagonals are created by connecting non-consecutive angles. So essentially the angles opposite, if you were to connect those, that makes the diagonals. So in this case, the diagonals are length BD and length AC. So if this is a parallelogram, then the diagonals will bisect or cut one another in half. So essentially what that makes is a midpoint here where those two diagonals intersect. So AM will be equal to MC because the one diagonal bisects AC, and DM is congruent to MB because the diagonal AC will bisect diagonal DB. So the diagonals bisect one another. They cut each other in half. Now, one thing you need to be really careful of is that does not mean that they are 4 equal parts. If you notice, my one diagonal is equal to the other part of that diagonal, and then the second diagonal AC is cut into a part equal to its other half, but they are not all 4 equal parts. Example 3 says, given that FGHJ is a parallelogram, we need to find the length of MH and FH. So we're looking for MH first. Well, since it's a parallelogram, we know that the diagonals bisect one another. That makes M, or where they intersect, a midpoint. So essentially, MH is just equal to a length of 5 units. It then goes on to say, what is the length of FH? Well, FH is simply that entire segment, so 5 times 2, or a length of 10 units. Go ahead and try the You Try Now. If you have questions about those, please ask at the beginning of class tomorrow, and have a good day.